Good afternoon, students. In the previous class, we have learned the topic applications of equilibrium constants. Applications of equilibrium constant. What are the applications? Predict the direction of a reaction. Next application, predict the extent of a reaction. Third application, predict the equilibrium concentration of reactants and products. Here first two applications already we learned. Now we can see the topic. Third application, predict the equilibrium concentration of reactants and products. So predict the equilibrium concentration of reactants and products. Predict the equilibrium concentration of reactants and products. Here listen, you consider one equilibrium reaction. You consider one equilibrium reversible reaction. So here you consider the first, you consider the example hydrogen. So hydrogen plus iodine gives, you get the product hydrogen iodide. So hydrogen reacts with iodine gives hydrogen iodide. If you are balancing, here you will get 2 hydrogen iodide. Understand? Here listen, here you can write the reactants and products. In this equation, reactants are hydrogen and iodine. Hydrogen and iodine are the reactants and hydrogen iodide is the product. Hydrogen iodide is the product. Understand? Now listen, in this equation you can write the concentration of reactants and products. You can write the concentration of reactants and products. So how we can write the concentration of this reactants and products means just draw one column and just consider these values. So here what are the reactants present? You know reactants are hydrogen and iodine. Hydrogen and iodine. And which one is your product? Product hydrogen iodide. Hydrogen iodide. Understand? Here listen, first consider, the first step you consider initial number of moles. Initial number of moles. Hydrogen and iodine initial number of moles A and B. These two only reactants. So hydrogen and iodine initial number of moles A and B. But hydrogen iodide product. So initially you won't get this product. Understand? Then second step, you can consider number of moles reacted. Number of moles reacted. Number of moles reacted. Number of moles reacted, you can consider reactant hydrogen X, iodine X, and this product hydrogen iodide 0. Product hydrogen iodide 0. Understand? Then in the third step we can consider number of moles at equilibrium. Number of moles at equilibrium. Number of moles at equilibrium means you can subtract this number, initial number of moles and number of moles reacted. You can subtract the initial number of moles and number of moles reacted. So you can subtract, if you are subtracting A minus X, here B minus X, and here this is not 0. Number of moles means, see here 2 hydrogen iodide present, isn't it? This 2 and number of moles reacted, reactant side we taken X. This X react to form, you will get the product X only. 2 hydrogen iodide, so 2X. Understand? Then finally we can write one more step. This is only a topic. Concentration. Molar concentration. Molar concentration of reactants and products at equilibrium. Molar concentration of reactants and products at equilibrium means you can write the formula. Number of moles divided by volume. Number of moles divided by volume. So can you tell the formula number of moles? A minus X divided by V. Here you can write b minus x divided by v. And here 2x divided by v. Understand? So in this equation, from the tabular column we can confirm concentration of hydrogen. Concentration of hydrogen is equal to, tell the answer. Concentration of hydrogen A minus X divided by V. Then concentration of iodine you can write this one, B minus X divided by V. Understand? Then concentration of hydrogen iodide you can write 2X divided by V. Understand? See here, you know your reversible reaction. Tell the reaction. Hydrogen reacts with iodine, gives your product is 2 hydrogen iodide. Understand? Now listen, here you can write the equilibrium constant Kc. You can write the equilibrium constant Kc. Can you tell the formula Kc? Kc formula already we learned, isn't it? Concentration of product divided by concentration of reactant. So tell the formula. Product hydrogen iodide power coefficient 2 divided by concentration of reactant, concentration of hydrogen into concentration of iodine. Understand? Understand? Now we can substitute all the concentration values. Now only we return the concentration. So can you tell the concentration of hydrogen iodide? Hydrogen iodide concentration 2x divided by V the whole square divided by hydrogen concentration A minus X divided by V into B minus X divided by V. Understand how we can sort this answer? 2x divided by v the whole square. So you can write 4x squared divided by v squared divided by a minus x into b minus x divided by v squared. Understand? Then next continuously you can write. How we can write the next step means 4x squared divided by v squared into v squared divided by a minus x into b minus x. Understand? Understand? Then next here you can cancel this v squared and v squared. So your answer 4x squared divided by a minus x into b minus x. Understand? This is the formula Kc. So this is equilibrium constant Kc. Same way we can calculate the Kp also. So how we can calculate the term Kc means just apply the relation Kp Kc. So tell the relation Kp and Kc. Kp is equal to Kc into RT power delta Ng. Tell the formula. Kp is equal to Kc into RT power delta Ng. Here you can calculate the delta Ng. Tell the formula delta Ng. Delta Ng is equal to number of moles of product minus number of moles of reactant. Delta Ng means number of moles of product minus number of moles of reactant. So here, can you tell the number of moles of product? 2. And number of moles of reactant? Hydrogen 1, iodine 1. So can you tell the answer delta Ng? Product number of moles 2 minus reactant side hydrogen 1, iodine 1. So tell the answer 2 minus 2 is equal to 0. So delta Ng value is 0. So can you substitute the value? So tell the formula. Kp is equal to Kc into RT power delta Ng value 0. If anything power 0 means that is 1. So you can write the formula. Kp is equal to Kc. Kp is equal to Kc. Now substitute the value Kc. So Kp is equal to 4x squared divided by a minus x into b minus x. Understand? So this is the relation. This is the formula. Equilibrium constant Kp and Kc. Equilibrium constant Kp and Kc. Understand this? Understand? Any doubt? Okay, one more time listen. We learned the example. Hydrogen iodide equilibrium constant Kp and Kc values. Here first draw this tabular column and consider all the values. Initial number of moles A and B. Number of moles reacted X and X. The number of moles at equilibrium A minus X, B minus X, this one 2X. Then molar concentration you can write. Hydrogen A minus X by V. Iodine B minus X by V. Hydrogen iodide 2X by V. Understand? See here, now we can write the Kc formula, Kc. Then just substitute all the concentration values. If you are substituting, you got this answer, Kc. Then how we can calculate Kp means, just write the relation Kp is equal to Kc into RT power delta Ng. Here first calculate delta Ng value. Then substitute this value. So Kp is equal to Kc. So the two values are same. Understand? Okay, see the second example. Dissociation of PCl5. Just write the equilibrium constant Kc and Kp values of dissociation of PCl5. So first you can write the reaction. So see, you can write the reaction PCl5 dissociation. First PCl5. This PCl5 dissociation means breaking. So this PCl5 dissociates to form, you will get the product PCl3 and chlorine Cl2. PCl5 dissociates to form PCl3 and Cl2. So PCl5 to form PCl3 plus Cl2. Understand? So here also, like the last method, you can consider this values. Okay, see here first, initial number of moles. Initial number of moles. Initial number of moles. And here you write the reactants and products. Which one is your reactant? PCl5 and product PCl3 and chlorine. Product PCl3 and chlorine. Understand? So here also same way, initial number of moles, reactant this one only. So A, product, two products are 0. Understand? Then second step, number of moles reacted. Number of moles reacted. Number of moles reacted, you can consider this one X and these two values are 0. Understand? Then third one you can consider number of moles at equilibrium. Number of moles at equilibrium, that one just to subtract A minus X. Then this one PCl3 and 1 chlorine. So you can write X and this also X. Understand? Then in the last step you can write molar concentration. Molar concentration. Molar concentration formula already we learnt. Number of moles divided by volume. So you can write this is A minus X divided by V, and this one X divided by V, and this one X divided by V. Understand? Understand? So from this you can write the concentration of these three values. So tell the concentration. So first, concentration of PCl5 is equal to A minus X divided by V. Then next, concentration of PCl3 is equal to X divided by V. Then one more value, concentration of chlorine is equal to X divided by V. Understand? Now you know the equation, just write the Kc formula. So you know the equation, tell the equation. PCl5 dissociates to form PCl3 plus Cl2. Here can you write the Kc formula? Tell the formula Kc. Kc is equal to concentration of PCl3 into concentration of Cl2 divided by concentration of PCl5. Can you tell the concentration values? First PCl3 X divided by V, chlorine X divided by V divided by A minus X divided by V. Understand? You can sort this value. X squared divided by V squared into V divided by A minus X. You can cancel this V and here one V. So tell the answer. X squared divided by V into A minus X. This is Kc value. Understand? Any doubt? Okay, then same way you can calculate the Kp value. Tell the formula Kp. You can write the relation Kp, Kc. Tell the formula Kp is equal to Kc into RT power delta Ng. Kp is equal to Kc into RT power delta Ng. Here calculate the delta Ng value. Can you tell the formula delta Ng? So how we can calculate delta Ng? Delta Ng is equal to number of moles of product minus number of moles of reactant. Number of moles of product minus number of moles of reactant. So product PCl3 and Cl2. So 1 plus 1 minus reactant 1. So your answer 2 minus 1 is equal to 1. Understand? Okay, see now we can substitute the value delta Ng in this Kp equation. So tell the equation. Kp is equal to Kc into RT power delta Ng value 1. So your answer correctly, formula correctly, Kp is equal to Kc into RT. Understand? Now listen, you know the ideal gas equation. Ideal gas equation. Ideal gas equation is PV is equal to N into RT. PV is equal to N into RT. From this calculate this RT. So you can write the equation RT is equal to PV divided by N. Substitute this RT value in this equation. So tell the answer. Kp is equal to Kc into RT value PV divided by N. Now we can calculate this N value. N means total number of moles of reactants and products. N means total number of moles of reactants and products at equilibrium. Total number of moles of reactants and products at equilibrium. So here total number of moles means you know already. See total number of moles at equilibrium, this one PCl5 A minus X, PCl3X and Cl2X. Sum of this value only we are telling N. Understand? So how we can calculate this? So okay, tell the number of moles value. A minus X plus X plus X. You can cancel minus X and plus X. So your answer N is equal to A plus X. Understand? Now we can substitute this N value in Kp equation. So if you are substituting, tell the formula Kp. Kp is equal to Kc into PV divided by N value A plus X. Understand? Now we can substitute Kc formula. Kc formula you got Kc is equal to, so Kp is equal to Kc value x squared divided by V into A minus X. X squared divided by V into A minus X into PV divided by A plus X. Understand? So now how we can sort this? You can cancel this V and this V. So your answer x squared divided by x squared P divided by A minus X into A plus X. Understand? So now this you can write A minus B into A plus B is equal to A squared minus B squared. So you can substitute this formula. So you can write the Kp formula. Kp is equal to x squared P divided by A minus X into A plus X. So that you can write A squared minus X squared. Understand? So this is the relation Kp. So Kp is equal to x squared P divided by A squared minus X squared. Understand this relation? Okay, one more time listen the relation dissociation of PCl5. First write the dissociation reaction. Then consider this all the values. NCl number of moles reacted, number of moles at equilibrium, molar concentration. Then first write the formula Kc and substitute all the concentration values and you got this answer. Understand? Then you can calculate Kp. For calculating this Kp, we taken this derivation. Kp is equal to Kc into RT power delta Ng. First calculate delta Ng, then substitute. If you are substituting, you got this answer into RT. So from the ideal gas equation, just apply the RT formula. Then there we can calculate N value. N is equal to total number of moles. If you are adding all the number of moles, you got the N value. Then substitute the N value and Kc value. If you are substituting all the values, you got the Kp answer x squared P divided by A squared minus X squared. Understand? Okay, listen. See, then we can see the third example, synthesis of ammonia. Synthesis of ammonia. So how we can prepare this ammonia? How we can synthesize ammonia means nitrogen reacts with hydrogen. Nitrogen reacts with hydrogen gives, you will get the product ammonia, N gets 3. If you are balancing, you will get the product 3 hydrogen and 2 ammonia. Understand? Now here also same way you can consider this tabular column. NCl number of moles reacted, all the values you can consider. So first you can write NCl number of moles. NCl number of moles. So here first write the reactants and products. What are the reactants present? Nitrogen, hydrogen and product N gets 3. Understand? So here can you tell the NCl number of moles of nitrogen? Nitrogen and hydrogen A and B, N gets 3, 0. Understand? Almost these 3 examples are same only. Then second step we can write number of moles reacted. Number of moles reacted. Number of moles reacted, these 2 molecules you can write X and this is 0. Understand? Then third step we can consider number of moles at equilibrium. Number of moles at equilibrium, that we can write as to subtract the number of moles. Subtract the number of moles. So here this is A minus X and this one B minus X and here this is B minus, not B minus X. See here 3 hydrogen present. See the example, 3 hydrogen present. So here you can write not symbol X, 3X. Number of moles reacted is nitrogen X, hydrogen 3X and NH3 0. Now this one you can write A minus X, here this one B minus 3X and here 2 NH3, so 2X. Understand? Now in the last step you can write molar concentration. Molar concentration. Molar concentration means, see, molar concentration means number of moles divided by volume. So A minus X divided by V. Here B minus 3X divided by V. And here 2X divided by V. Understand? Understand? So now listen. From the equation you can write the Kc formula. Can you tell the formula Kc? Kc is equal to concentration of product NH3. Concentration of NH3 power 2 divided by concentration of N2 into concentration of H2 power 3. Understand? Now we can substitute all the concentration values. Can you tell the concentration? First concentration of NH3, this one, 2X divided by V. 2X divided by V. Then concentration of nitrogen, A minus X divided by V. Concentration of hydrogen, B minus 3X divided by V. Understand? Now we can substitute all the values. So tell the answer how we can substitute the values. First NH3 concentration 2X divided by V the whole squared divided by N2 A minus X divided by V. A minus X divided by V into H2 B minus 3X divided by V the whole power 3. Understand? Now we can sort this derivation. How we can sort this? 2X divided by V the whole squared. So you can write 4X squared divided by V squared divided by A minus X into B minus 3X the whole cube divided by V into V cube. Understand? Now this derivation you can write like this. 4x squared divided by v squared into this v into v cube we can write v squared into v squared divided by a minus x into b minus 3x the whole cube. You can cancel this v squared and this v squared. So you can write the answer Kc is equal to 4x squared into v squared divided by a minus x into b minus 3x the whole cube. Understand? Okay, see now here you can calculate the Kp value. Now Kc value you got. For calculating this Kp, just write the derivation. Kp is equal to Kc into RT power delta Ng. Kp is equal to Kc into RT power delta Ng. First calculate the delta Ng value. So how we can calculate delta Ng? Delta Ng is equal to, tell the formula, nitrogen plus 3 hydrogen gives 2 NH3. So number of moles of product minus number of moles of reactant. Here product 2 minus reactant 1 plus 3. Understand? So your answer 2 minus 4 is equal to minus 2. Now we can substitute this delta Ng value in Kp equation. So tell the answer Kp is equal to Kc into RT power minus 2. RT power minus 2. Understand? From the ideal gas equation, you can write the RT formula. Tell the ideal gas equation. PV is equal to N into RT. From this RT is equal to PV divided by N. You can substitute this value. So tell the formula. Kp is equal to Kc into RT value PV divided by N power minus 2. So this, instead of minus 2, you can change this minus 2. So how we can change? Kp is equal to Kc into PV by N power minus 2. That you can write like this. N divided by PV power 2. N divided by PV power 2. Understand? Now listen, you can substitute this N value. Can you calculate the N for N value? N means you know. See, N means you know sum of the total number of values. So sum of a minus x, b minus 3x and 2x. Understand? So tell the N value now. N value a minus x plus b minus 3x plus 2x. Understand? Now this one you can write a plus b minus 4x plus 2x. That you can write like this. A plus b minus 2x. A plus b minus 2x. Understand? Okay. Now we can substitute this N value in this equation. So tell the answer. Kp is equal to Kc into N value a plus b minus 2x divided by 2x the whole square divided by PV the whole square. So that we can write P squared into V squared. Understand? Now here you can substitute this Kc value. Tell the formula Kc. So you can write Kp is equal to Kc value, you can write Kc value 4x squared into V squared divided by a minus x into b minus 3x the whole cube. And into this value a plus b minus 2x the whole square divided by p squared into v squared. You can cancel this v squared and v squared. So tell the answer now. 4x squared into a plus b minus 2x the whole square divided by a minus x into b minus 3x the whole cube into p square. Understand? See, now here you got the answer Kp. So in this equation also you got the answer Kp and Kc values. Understand? One more time you can see this relation. Synthesis of ammonia. First write the formula how we can prepare ammonia. Then just consider this tabular column. There you can write the concentration of these three values. So from that first you can calculate Kc value, Kc formula. Just apply all the concentration. If you are applying, you got the answer Kc. Same way you can calculate Kp. For that just write the relation Kp is equal to Kc into RT power delta Ng. First calculate delta Ng. Then from the ideal gas equation calculate RT, then N value. After calculating N value, substitute all the values and calculate. You got the answer Kp. Understand? This is the derivation Kp and Kc values of synthesis of ammonia. Understand this? Any doubt? Okay, see, now take page number 12. Page number 12, note the question. This is one of the important 5-mark question. Derivation of Kp and Kc values of formation of hydrogen iodide. Note the answer from this to page number 12. From the second tabular column, right side second tabular column. Let us consider the formation of from this to here the same derivation only. First this tabular column, then Kc value, then Kp values. So till page number 13, till this Kp value. Kp is equal to 4x squared divided by a minus x into b minus x. Understand? Okay, now second question. This one also important question only. The three derivations are important. Second question, Kp and Kc values of dissociation of PCl5. Dissociation of PCl5, that also the derivation fully. Consider A moles of, from that to till the next page, till page number 14. Till page number 14, before the synthesis of ammonia, till this Kp value. Understand? Then continuously next question, the same page, page number 14, synthesis of ammonia. This also important 5 mark question. Mark the answer. Let us consider the, from this to till the same page, page number 14, before the solve problems, till this Kp value. Understand? Okay, see now we can note the tomorrow's homework. This three derivations. Formation of hydrogen iodide, page number 12, formation of hydrogen iodide, page number 13, dissociation of PCl5, page number 14, synthesis of ammonia. These 3 5 mark questions learned thoroughly. Understand? Okay, thank you.